In chapter 16, we did the one mean z interval with the panic method. So in this chapter, we're going to do the one mean z test. And I have a new mnemonic for you that's very similar to the last one, and this one is called phantoms. So these two processes belong in the same family. This is the one mean z family, a one mean z interval, and a one mean z test. And these are both based on the normal distribution. So this is our tie-in from chapters 3 and 15 that are going to help us move forward with our statistical processes. All right, so let's break down phantoms. The P is a parameter statement. So just like with panic, you're going to identify what you're being asked to do, which is typically something related to the alternative hypothesis. The H is going to be the hypotheses. So you want to identify the null and the alternative hypothesis. The A is our assumptions and conditions. So these are the things you have to check in order for this test to be valid. So they'll be the same ones that we used in 16, which is the random sample, either normal and large, and then the population standard deviation. Once you have that, then the name of the process you're doing is called the one mean z as in zebra test. So we're using that normal distribution, and that's what that z is indicating. In chapter 20, we're going to switch from the population standard deviation to the sample. And so we'll switch to a T as in tiger distribution. This is kind of why I keep making a point of emphasizing that, because I know it can be really tricky to catch those. Our test statistics. So we did look at this briefly earlier, and we're going to look at it again. This is Z is equal to X bar minus mu divided by the quantity sigma over the square root of n. So you can certainly use a calculator to do this, but I also have a spreadsheet built for you in Excel, and we'll take a look at that too in just a little bit. So the O in phantoms is obtain the p-value. And so you can either do that with the Rossman Chance app, or the Excel spreadsheet that I have built for you that finds the test statistic will also find that p-value. Okay, the M is make a decision. So this is either do or do not reject the null hypothesis. And then S is state your conclusion, much like it was in the C in panic. It's kind of a fill in the blank sentence. So you're always going to interpret these results in context of the alternative hypothesis. So these parts that are highlighted and underlined would be the parts that you're going to fill in each time from your story. So with a p-value of 4%, at the 5% significance level, so that would be our alpha, we either do or do not. So in this case, we do have sufficient evidence the mean height of Western students is greater than 60 inches. All right, so there's the process. And in the next video, I'm going to walk you through this problem using this process. All right, so I want to go through these assumptions and conditions again and just how to mark or notate those. So simple random sample, if it's on there, you can put a check mark, you could put stated. If it's not told to you and you don't have a reason to assume it's random, put a little star and put not stated, just like we did in chapter 9 with those experiments. The normal large part, so if the problem states that you can assume it's normal, then you can just circle the word normal and put stated. If the sample size is bigger than 30, then the central limit theorem kicks in. So write the sample size down, n equals 30, and circle the word large. If your sample size is less than 30 and you have a data set, you should make the normal probability plot. So do that, and as long as it's straight enough, or maybe a little bumpy might be okay, depending on the size, you can circle the word normal and put a little star that says NPP. If your sample size is less than 30 and you don't have a data set and you have no reason to assume this is normal, you need to put a star down and say that this is unknown, and that would definitely be something that would be concerning in terms of looking at your conclusions. And then the last one is that population standard deviation sigma, and that has to be given to you in the context of the problem. All right, so let's take a look at what this test statistic is going to look like and then the spreadsheet. So our test statistic is X bar minus mu divided by sigma over the square root of n. So hopefully by this point, we're feeling pretty comfortable with what these symbols represent, but let's run down it quick. X bar is going to be the sample mean that comes from your data. Mu is going to be the null hypothesis value. So whatever you wrote down when you wrote the null hypothesis and you said mu is equal to, that's the number you're going to use here for mu. Sigma is the population standard deviation, and that'll be given to you in the problem. And then n is the sample size. All right, so here's what the spreadsheet is going to look like. So there's a spot to put your X bar, a spot for the mu or your null hypothesis mean value. your population standard deviation sigma, and then your n, your sample size. It'll give you the value of the test statistic, and then it'll also give you the p-value for a left tail, a right tail, or a two tail. So you have to look at your alternative hypothesis and decide which one of those three you have, and then write the probability down that goes with the type of alternative hypothesis you have. All right, come back in the next video. We'll go through phantoms together, and I'll show you this spreadsheet.